Good afternoon, sir.
Good afternoon.
Sir, voice is not audible.
Oh, okay. I haven't spoken anything yet. So is it audible now?
Yes, sir. Yes, sir. I thought you were speaking with me.
No. I didn't.
Yes, sir. Sorry, sir.
No, it's not. Are the students joining? Should we wait for some time?
Yes, sir. Just 2-3 minutes, sir. At
Okay.
1:10 you will start, sir.
Okay. Fine.
Yes, sir. Okay, sir. Sir, you can start, sir.
Okay, fine. All right. Okay. Good afternoon, everyone. I see students are kind of not joining in, and as you keep joining in, that is great. So today we will talk about a very interesting topic, and it's one of the applications of data science and analytics right? Which I think is a very hot topic in the industry anyway, in the sports and the sporting industry, right? I'm sure most of us kind of love sports or follow certain sports, etc. And even if you don't, I'm sure you would see your friends and families and colleagues and everybody do follow some sports or the other. There's always that excitement around sports, and what goes behind the sports is something which is very, very interesting and intriguing, because there is a huge science that works behind, and that science is nothing but looking into the analytics, doing the analysis, figuring it out, that how a data can help a sportsman in a particular way. And as you know, that all the sports management teams nowadays, they rely very, very heavily on the data and the analytics. There are specific roles, there's specific career options, which is available, which talks about and which facilitates how you use the data and analytics to predict a particular pattern, or identify how to improve. For example, if a sportsman is making a certain errors, then you can point that out. If the sportsman is doing something well, then you can call that out, what's the percentage of shots that the sportsman is going to play, etc. Right? So there are various things that you can do with analytics, data science in the sports industry. So if this is one of the career options, is what you're thinking, it might be helpful. But even if it is not a career option, you will still find this very interesting as a use case, that how sports and data science analytics are go hand in hand together, right? So today we will listen to that from one of the experts in the industry, and I will play my videos, um, and then this is basically about the journey of Ken, the instructor, and how Ken basically uses data science in the golf as a sports. The example taken here is the golf as a sports, but something like this can be used across any, be it a cricket or a football or a tennis or a badminton, etc. Right? So there is no stopping that. Computer science versus data science, and how they work together, using simulation to develop the speed, etc. Right? Then how do you create a specific content, and how do you use your data science skills once you get the job, etc. It's something what we will see. It's a very interesting journey from one of the folks in the industry, and a lot of people are taking up these career options a lot, right? So let's listen. Let me share my screen, and let me know if you're able to see my screen now. Are you able to see my screen now? Okay, I can see participants can see your screen. All right. So I'll be playing the video. Let me know if you're able to hear the sound.
This is an audio course.
Are you able to listen to it?
Yes, sir.
Okay.
Thank you for listening.
Okay.
Math is unbelievably important in the domain, but if you know how to program, you can implement the math. You can get your hands dirty. You can experiment with it. You can use the random number generator to understand how distributions work.
That was Ken G, a fellow content creator here on YouTube and someone that teaches a lot of people how to get into data science. And he is someone that didn't start on that path, but found his way into it and has learned a lot and is kind enough to share it on his YouTube channel and here with us today. So without further ado, here is my interview with Ken G.
So an important thing to keep in mind is, as you are listening through this entire presentation, you will find that Ken didn't start as a data scientist. He found his way around. So a lot of you folks may be actually studying data science, actually may even be wanting to be in this field of analytics. So either or, I think you can listen and understand that how typically a journey can be. And this is a real life story, right? So hence, let's listen to see how Ken came up to be a data scientist, and then how did he grow in his career. And this entire thing is in an interview format.
Mr. Ken G, welcome to the podcast. This is the Free the Data podcast, where we talk with folks like yourself to learn what you've learned. Is it Ken is your full name, or is it Kenji G? Because that would be awesome.
It's Kenneth G.
Dang.
Yeah, and then a lot of people call me Kenny G after the
nice.
saxophonist / oboist.
Yeah.
And but it's usually a certain band of age that is familiar with him, so not not many of my like direct peers, but
come on, Kanye had Kenny G do the thing for Kim when they were, no, it's such a weird coincidence. Like, I have two friends whose last names complete their first names, so I was secretly hoping your first name was Kenji and then it would be Kenji. The other one's like Mike Cole, so it's like Michael. And Steve Vaughn,
cool.
where it's Steve Vaughn. And I'm like, that's how crazy is that you named your kid a thing that would, anyways.
Well, my girlfriend hates.
Well, this is the fun part of it, just the introduction of the author, etc. In a podcast kind of in a scenario when it's an interview kind of in a format. Let's now move on to how did Ken actually start his journey into data science?
All right. Well, before we get too far off topic here, can you let everyone know listening what you do and how you got there? And then I just kind of want to rewind the clock back into there and just probably ask a lot of questions as we go, because I think it's kind of a cool story and people need to hear it.
For sure. So my main work, I'm the head of data science at a company called Scouts Consulting Group. So the mission of Scouts is we help athletes and teams improve their performance by analyzing the data that's collected on them. So we work primarily in golf. We've also worked in basketball. We're kind of exploring some other sports as well. It's very focused on the performance side of things. So our goal is to help teams win, basically, or help athletes improve their odds of winning or competing or signing a bigger contract or whatever it might be.
So if you're thinking of a career in sports management, which is to do with analytics and data, I think these are few of the goals and objectives you may want to keep in your mind. So if somebody asks you, okay, fine, why do you want to do what you want to do in the sports and analytics? Then it could be improve the performance of the player, improve the performance of the team, make the team a winning team, right? Or help a particular sports person get and have a higher contract, and something which Ken is talking about here. So to keep in mind that what could be the various objectives of this role, and if you are taking up a role, something like this, right? So let's listen.
So to me, there's some, a lot of fun elements associated with that. I'm probably better known these days for the content that I create on YouTube through my YouTube channel, just Kenji. So I make a lot of introductory data science content, a lot of projects that I do, as well as my podcast, Ken's Nearest Neighbors, where I hope to have you on one day to talk about the experience there.
Totally.
and those types of things. So yeah, it's been a pretty cool journey across those things. I also I like to stay busy, so I've created this initiative, the 66 Days of Data, which is something that anyone can join. It's just about creating good data science habits, which I think is something that is overlooked in this field.
So at any point in time, you want to learn more about the content that Ken is creating in the data science, you can obviously go to YouTube and search for Kenji and data science and sports, and you will find more. But here he's talking about what kind of different content has he created and why he's doing that, right? So that's also additional material for you to learn.
So many people focus on, hey, how do I land this job? How do I get to this next level? How do I learn this skill? That once they achieve these milestones, they're sort of lost, right? And data science is a domain where you have to continually learn. You have to keep evolving. You have to keep growing. And that's what the challenge is all about, is creating that habit of continued learning and also accountability with your peers and sharing across different platforms.
So very important thing to keep in mind that data science, whether it's in sports application or anywhere, it's a continuous learning and evolving of a journey. So it's not that I learned data science today and that's it. I'm done with it. You have to continuously keep evolving. You have to continuously share, learn the new things, because this field itself is very, very upcoming. This field itself is very dynamic. There is always something or the other that is evolving, right? So, and that's the advice that the author Ken here also gives us.
Okay,
love
so
it.
60 days of data, was it? Or
66 days of data. So one of my favorite authors, I think it's James Clear, he wrote the book Atomic Habits.
Mhm.
And he talks about how the average amount of time it takes to ingrain a new habit is 66 days. So I thought that was something unique. Everyone's doing 100-day challenges. Why not make it something a little bit different?
Yeah.
And a lot of people ask questions about that, which makes the challenge kind of perpetuate further. It's like, why is it 66 days? This and that. As a data scientist, though, I do realize there's a problem with using averages. So I try to
Yeah.
be very clear that 66 days is the average. I don't know what the distribution is. A lot of these
I mean,
things.
is it what's the median? You know, like let's get
That's a
to
good
it. What's the
question.
upper quartile? What's the lower quartile? Come on.
I hope the median is also 66. And
Or
we'll just
close
work
to
with
it.
a nice normal distribution. I would imagine it's close to it.
Right. So while this is more about like the content that Ken has created, which he's naming it as 66 days of data, and which is fine to know, and you can always go and search in YouTube, etc. Let's move to see how he is kind of using data science in golf as a sport. So we take an example of golf as a sport, but the basic principles and the basic fundamentals can be attributed to any sports for that matter. It's all about developing a process. It's all about developing a habit. It's all about using the data to kind of analyze the pattern, etc., to make an impact, right? So let's hear about the use of data science in golf.
Let's talk about the sports side of it, though, because this is fascinating to me. I'm a golfer, I mean, I don't know if what I do can be called golf, but I hit a little white ball around a field and I have fun doing so, and I pay a lot of money for it. Talk to me, like, what in the world of golf are you tracking? And like how does that work? Like, what do you track and how do you use that to actually improve someone's golf game? Because I'm very selfishly interested in this.
Yeah, well, so the nice thing is we don't really have to track anything. So the PGA Tour at every tournament, they use a system called ShotLink. And ShotLink takes the location of every shot, where it ends up, the lie characteristics, how far it goes, a lot of different things. They even have the weather and those types of variables. And we use that data to evaluate how players will play on new courses. We use that data to evaluate trends in players' games. Our biggest client is the U.S. Ryder Cup team. So we effectively help them to think about how to pick the team, use some quantitative metrics to evaluate that. At the end of the day, it's the captain's decision, but we try to help them in a more quantitative way. And we also think about who should play together in the pairings and those types of things, especially across the different formats, which is a very fun intellectual challenge.
I was going to say that probably throws. It's not just like a regular, one-on-one tournament. It's kind of unique in how it lays out like that. And so, yeah, you're kind of moneyballing it, right? You're kind of saying, hey, so it's not about who shoots the lowest score overall or whatever. It's about who gets on the fairway the most, or who gets on the green the best, or whatever, right? Whoever leaves it the closest to the pin usually. So you want DeChambeau, and then you want Xander or somebody else paired up, because they can complement each other or something like that.
Yeah, and to be honest, it's a lot of people say, oh, you want like the long guy with the good putter or whatever it is. It depends on the course. It depends on who's playing the even holes and the odd holes, especially in the alternate shot format. And we do a lot of pretty complex analysis, a lot of simulation, a lot of these types of things to evaluate not just if they would sort of fit well on at a high level. Conceptually, it makes sense that it would work together. But we also look at it based on thousands of simulations if they would work together well, which I think is
fascinating.
Well, so they're also they rarely play the.
So key thing to remember here is in terms of the analysis, right? While he's talking about the golf, it's a individual sport. At the same time, it's a team sport as well, because he talks about the US Ryder. So there are multiple collective people who might be playing this sport as a team as well. There are some competitions in golf which are very individualistic, but there are some where a group of people kind of participate. So if you see the questions that the interviewer kind of asks here is, what kind of data do you analyze, right? And he gives an example of ShotLink, which is the software which kind of gathers the speed at which you move the bat, or the speed at which the ball kind of flies, what is the wind direction, etc. So all those various statistics is something that is possible. But typically in a sport, people would always ask, okay, fine. So who should be playing? I mean, is this a tall guy who should be playing, or is this I'm short, and then will I be able to make that kind of impact, or will I get that power, etc. Right? So the author says here, see, it's not about how you are built or how you are whether you're long, whether you're short in height, or you're long in height, etc. It's all about the golf course. If the golf course, every golf course is uniquely designed. Every golf course has external factors like the wind, flow, direction, etc. Right? Every golf course will be uniquely how many holes there are going to be in terms of putting, etc. Right? So different golf courses have different challenges. So based on the data, you can analyze that what is the probability. So there's a lot of mathematics that goes into it. So what is the probability that a person X may be able to hit a particular shot in a particular way in a particular golf course? Previously, what has this person done? If there is an external wind factor, then how do we negate that? So all of these things together, you package and you present to the team. And of course, as he says, it is ultimately up to the captain to decide whether he will be taking that data or whether he'll be looking at something else. But what helps the captain and the team and the sports person is to, when you have the data in front of your eyes, at least there's a trend, there's a pattern, there's an analysis, and based on that is how you can take a decision. So this is how typically it works. So and that's what the author also talks about here. So let's listen more what he says.
The Ryder Cup courses during the season.
Uh-huh.
So we have to evaluate.
Yeah. Okay, the fairways are this hard to hit. So that's similar to this course. Who played well at that course, right? Yeah, that's amazing. I would love like that is a job I could have, just looking at golf data like that all day long. Like I could totally, because I live in San Diego. I just played Torrey South this past Sunday, and it's in prep for the Farmers, which is happening next week. And holy cow, the rough is a Gatorade bottle deep. So, things like that. It's like, yeah, Ben's chance of getting out of the rough, 0. This is an easy, So I would love to see, how that plays for everyone else.
Well, yeah, I mean, it's an interesting thing. I mean, people are talking a lot about the data around hitting it further. And that's a big point of contention. Bryson DeChambeau is essentially breaking records, making them change rules about driver length and a lot of those things. Mm-hmm. All the rules that they're creating to negatively impact a Bryson DeChambeau type player, they don't affect him, right? Like he doesn't use an extra long driver. If they grow out the rough or they make the course harder in that way, he has a wedge in from the rough. Whereas even if people are hitting it shorter but more in the fairway, when they do miss a fairway, they have like a 5-6 iron out of the rough, which is penalizing them even more.
Way more.
And so it's an interesting thing from a data perspective to look how the game has evolved and to look at what's valued in different ways. And I will say, from looking at the numbers, it isn't always just hitting it further that is what can change the game and help you improve the most. For the history of golf, the place where people could make the largest improvements and that they had the largest relative advantage in the game compared to others is the iron play. So on average, the person who is picking up the most shots on iron shots is picking up, half a shot, a full shot on the field. Whereas with the other categories, it's usually significantly less than that.
So again, another very important point that comes in from a analytics point of view. So here the author says that typically when somebody talks about a golf, how far can I hit the ball? Is that the only question I need to answer, or there are multiple other factors as well? So he talks about iron shots. So how do if somebody is taking an iron shot, then probably the person's strength is better, and that person will be able to hit the shot much more further, right? So which means what preparation goes in even to become a player. What is your routine? What kind of exercise should you be doing? How much time would you be spending in a gym? in the gym, like, if you are a golfer, then like, if you have to swing your stick, then what kind of exercise should we be doing and how much time would we be spending? So much of analytics and details actually kind of goes into the and in preparing and understanding that, like, how does one become a strong golfer. So it's not so analytics. So thing to keep in mind is, it is analytics and like data science is not necessarily just one simple straight line linear answering of questions, like how far can I hit the ball, but what goes behind it, what should be the length of the stick. If I use a length of a stick which is 6 meters versus if I use a length of a stick which is 4 meters, then what kind of grip am I kind of holding on that thing, and how far am I kind of going ahead with those kind of shots, right? So those measurements, those analysis, everything gets into, like, making a player successful. So it is that intense, right? So having talked about this, the data science behind it, let's also understand, how do you transition? So what is the difference between a regular computer science versus a data science, right? I think it's also important to understand, a lot of times people kind of mix the two together. So how is that different and how is that applicable? Let's see that, right?
But computer science isn't data science. So how did you make that transition, and what's that like, right? Because you were already with an economics background, you're basically doing data science type things, right? You're trying to solve problems by looking at the data conceptually, but you're not using, the tools and methods that a true data scientist would use. So did you learn that in getting your degree in computer science? And if so, like, what was that transition like?
Yeah, so I was very meticulous with choosing a program. So the one I went to was at DePaul in Chicago. I actually moved out there. I spent about 5 years in Chicago. And what I liked about it is it was unbelievably flexible. I think I had like 4 core classes I had to take, and then the rest were all electives.
Oh, cool.
And at DePaul, you also had a predictive analytics program, which was essentially a master's in data science program. And I could take all of the classes without having to take the prerequisites. So I went in and I did all the computer science classes, which I thought was going to be relevant anyway. I have some entrepreneurial, an entrepreneurial itch. And I was like, hey, if I can do software engineering stuff, I can build whatever I want. Not necessarily the case. It's a lot harder than just learning the skills. But
yeah,
I was like, hey, the world is my oyster if I do that. And then all of my electives, are like 80% of my electives, I spent on machine learning classes. And I had taken some, with very basic data visualization and stuff in my previous degree. So I was like, hey, I can skip over those and take the more advanced ones and not worry about it. So I took, 2 or 3 machine learning classes, a data analysis course, and a Monte Carlo simulation course, which is one of the greatest courses I've ever taken. I use simulation so much more in my work than anyone would expect. And it's such a useful thing, right? Like, rather than me having to derive math formulas, I can simulate it and get a pretty good idea of what's going to happen.
Yeah.
Right. So the key message there is, like, while Ken was kind of, developing and thinking of a career in data science, he went to a college and he decided that, along with data science, what are the other supplementary and complementary courses he can take, right? And this is quite true for, most of us as well. A lot of you may also be kind of, thinking of taking up certain courses, and you will be thinking that, what are the supplementary or complementary courses that you will be kind of taking, which will kind of help you, right? So he talks about computer science. And he had a software engineering background. So he talked about data visualization, which he had kind of done earlier. So how all of these together kind of helped him kind of think in terms of a data science is important. See, honestly, data science is not something which is standalone. It is a stream that has evolved in the recent years, where you have the scientific way of analyzing data. Data was always there in the past as well, but how are we analyzing data? How are we kind of implementing them in the particular use cases, in the particular fields, for example, sports or healthcare or anything for that matter? that art and the science is kind of coming together, and hence we are calling it that data science is a particular stream, right? So, but in order to become a data science scientist or a data science person, you also need to kind of have certain backgrounds which helps you to manage this data, because data can be extremely overwhelming. How do you typically interpret data? Like, how do you narrow down and filter the data, which becomes a more application kind of a cases, right? So it's also important to understand, like, what are the various other complementary courses that you may want to kind of take. And hence the author talks about that, computer science and data science, and together with his engineering background, how it has kind of helped him, right? Now, using all of these techniques, Ken is going to talk about how to use simulations to speed development. Like, how would you use various simulation models, which might be helpful for to derive and or rather arrive at analyzing how things are to be done, right? So let's listen to the story around the simulations.
Yeah,
And
explain this to me, because I think I've thought about this. I'm curious your thoughts on this, but I think it's very related. The difference between, say, a physicist and a data scientist is like a physicist wants to understand the laws that govern a thing and why it happened. Like, why did this tennis ball only, go so high after I dropped it from 3 feet? Whereas a data scientist is like, I don't really care why. I just want to drop the ball 10,000 times and measure exactly where it goes, and I'll be able to predict it from there. So it's kind of like two different approaches to the same problem of like predicting what will happen. And simulation is kind of how you do that, right?
I mean, that's exactly what it is. I mean, the way I look at it is you're exactly right. Is physicists are trying to model the world and create a formula that represents it every time. The data scientist is trying to derive as close to that formula as possible, because a lot of the problems we face in the world have too many variables to be able to derive a formula to within a reasonable amount of time. But I will say, I think a lot of the physicists that I've worked with have made incredible data scientists, because they understand the natural laws. They understand when formulas are available for the things they're trying to simulate already. And it's like, oh, I don't need to simulate this. I know there's a formula. But, they have this epiphany when it's like, oh my goodness, I don't even need to use a formula. I can simulate this out and I can save myself so much time. That tool in a physicist toolkit makes them such a powerful force in creating good data science outcomes for a company. To get there, it takes some relearning, I think.
Yeah.
And I hope my physicist friends will not get too mad at me, but I think that there's something to be said about those two different mindsets, and neither one is right or wrong. I think depending on the problem, one is usually more efficient than the other.
Very important message. So how does the mindset kind of help you to determine something? Now imagine in a sport like a golf. So a physicist would probably say, okay, fine, if you swing the bat in a particular angle, right, then the ball will fly in a particular direction, in a particular trajectory. That is what physics will talk about. But a data science will say, okay, how many times, if you do this 100 times, what is the likelihood of the effect? Maybe the first 10 times the ball will go in a particular distance. Maybe the next 20 times the ball will go in a particular distance, right? So how do I then ensure that multiple times of repetitive actions is giving me a trend, and how do I take that trend to analyze further and implement? I think that's the key difference, and that is what is called as a simulation, basically, right? The author here talks about bouncing of the ball 1,000 times, 10,000 times, and then that kind of gives a pattern. So similarly, in the sports implementation for a golf, it's important that while physics is a important part because it's an outdoor sports, but at the same time, data science is all about repetitive multiple actions of similar nature, which kind of helps you collect and gather data, which you analyze and then you predict. So your predictive analytics, your predictive how it is probably likelihood of things to happen is something what is possible with data science, right? And that's the key, because in any sports, ultimately you may have a lot of data, but how do you predict a possibility and which helps a player to adopt and try something different is important, right? So let's listen more.
And I think if all data scientists were physicists, the world would not work quite as well as it does. So
yeah, I mean, and you can't just run simulations and test everything, right? Like for example, we just put up the James Webb Telescope. Like, yeah, we need some hardcore physics and math proving that the $100 billion or whatever we spent to get this thing up there is like the chance of failure is so infinitesimally small. So yeah, we can do simulations, we can do the data side of it, but really I want like some physics here. I want to know that when this thing moves, it's not going to snap off or something, right? So yeah, you got to calculate the friction and the tension and all the other types of things that they would do. So no, I love that. Yeah, it's always been an interesting, it's like two sides of the same coin, right? It's like you're trying to figure this thing out. That's fascinating. So you picked up all these skills in your master's program, which is basically data science type stuff. And I mean, is that when you were like, okay, I am a data scientist, I'm going to teach it on YouTube? I mean, where?
So here it's talking about how to create that content, and Ken definitely has a lot of content that is created on YouTube, etc. So the interviewer asks him the question that how do you typically apply this knowledge to kind of create certain content for teaching, right? So let's listen to how he's using his skills to kind of develop content further, and then how does these, and then we'll hear how does this content, etc., kind of helps in the certain job that you are doing, or what's the job market for data scientists, etc., and what other new data scientists should learn from, right? I think those are things which will kind of come out. So let's listen to how did he transition from how did he apply creating that data science into the specific content?
Where did you go from there?
Well, no, so there was a long road before. Well, YouTube did start in grad school. So I made my first video. It was a project I had for one of my deep learning courses, and I had to submit it online. And I was taking the course online. I took 6 courses in person, and I was like, why am I doing this? There's no discussion. This makes no sense. The classes are 5 to 9 at night. I'm a zombie after 3 p.m.
Yeah.
So I watched the lectures in the morning instead, and it was a good solution. But one of the ways we could submit it was via YouTube link, and I didn't realize you could make unlisted videos at the time. So I just put it out there. I published a video, didn't use any tags or keywords or anything like that. I just put it as my presentation. And I don't think about it for maybe 3 months. And I look back and, I had like 100 subscribers or something, and people watched the video 1,000 times, something like that. And I was like, oh my goodness, like there's an appetite for this. This is really interesting. And I got to thinking, because I was, I just got my first data science internship. I worked at GE. And I was like, well, wouldn't my journey hopefully be helpful to someone else? I mean, there's a lot of people that I was talking to at the consulting firm that I was working at, and they're like, hey, I'm really interested in this data thing too. How'd you do it? And I forget who told it to me or where I read it, but the idea is that if you get asked the same question more than once, make a blog article or reproducible content about it. And so I made a video about how I transferred from consulting into data science. And, that video didn't do as well, but it still had traction. And I realized that, wow, I like making these videos. I like telling these stories. And at the same time, there was this really awkward moment that I had during an interview where it was a prompt on a screen and I had to talk into the camera and like answer the question, right? So I'm not talking to a person. They're just listening to my responses. And you watch it back after you do it.
Oh, wow.
And I watched it and I was like, who the heck is that? I would never hire that person. Right. And so I was like, well, how do I practice that skill? I mean, if the world is going to be technology driven, how do I improve on my interpersonal skills? And one of the best ways to do that is taking video of yourself and watching it back.
So here he's talking about how he's kind of using his skills to kind of create a content and creating those various courses. So that was all about his content thing. Let's kind of listen about how data science skills actually you need. What are the data science skills that you need when you're in the job? Like, let's say, for example, in this case, like in the world of sports analytics, like you're doing this job, what kind of skills do you actually need, right? And let's hear it from him.
Now, this new set, like, you know, what comes to mind is Gary Vee, and how when you're starting out in social media, if you're doing social, you know, online business or this stuff as a living, you look at it and you go, he is the ultimate hype man. You watch him, you get excited, you get some tips, you go do it. But then after you're doing it, you can't, like, I can't watch Gary Vee anymore because I'm like, I'm already here, man. I don't, you know, I'm already on the bus. I don't need like somebody to get me hyped to get on the bus. Now I need the tactician. Now I need the, hey, click this, do this. You know what I mean? The next level, right? So is that kind of the idea? Like, you've done the, hey, this is what you should know to get in. This is it. And then now that you're in the field, now that you're in the job, here's how you succeed. And if so, like, what are those lessons? Like what are the, you know, top 1 or 2 things that you think someone that has followed you for a long time, that is now working in it, what's the next chapter for them that you think that you could help them with?
Yeah, I mean, to be honest, I like dealing with the things that are less technical more. I think that those are the problems that everyone faces, and they're a little bit more universal. So, you know, dealing with multiple projects, right? If you're at work and you're trying to navigate, wow, how do I continue my learning outside of work as well? I mean, that's a really important thing. Like, how do I manage that? And a family in this time, like, time management is an important thing. There's also elements of just understanding like what the nature of the domain is, and career switching and doing a lot of these things. Like, it isn't easy to like, those are the things where you can't Google the answer quite as easily.
Yeah.
Right. And that's the sort of fit that I'd like to approach. I'm also very interested in storytelling, right? I don't think anyone is on YouTube because they hate telling stories, right? And there's so many cool things that are happening in the data space right now and always that I want to be able to highlight and sort of take out lessons from. So, for example, my video next week is on this guy, Bill Benter. So if you're interested in sports, Bill Benter is probably the most successful sports gambler of all time. They say he made close to $1 billion betting on horses in Hong Kong.
Wow.
Right. And to me, that's fascinating. Like, everyone talks about the story, how much money he made, all of this, but no one looks at no one like tries to break down the models he was using and explain why he was able to have that type of success in that space at that time. And so my video is like a deconstruction of like, okay, the models he used are public. He's written research about this. I like actually went through the research and looked at it. It's very simple. It's like multivariate logistic regression. It was in the 80s and 90s, right? Like, they weren't using as advanced stuff, but the feature engineering is something that he was doing that no one else was doing. He had access to data that a lot of people didn't have access to. And so there was an advantage that he had at the time that no one else had, and this understanding and this ability. And now if you do too well to a sportsbook, he'll get banned, right? And so it's like this perfect storm of why does this work in this specific scenario? And I did another one a while ago on Zillow and what happened there. You know, is that like a model failure, or is that a management failure? For those that don't know, Zillow lost a bunch of money with their iBuying, which is
right. So again, these are examples where, like, you know, the author talks about how do you use the data science skills to actually deconstruct a model. He talks an example of, like, you know, a particular person who made big money in like, you know, in racing. But people talk about, like, you know, making the money, but people probably do not break down the various models which like, you know, he would have probably used and deconstruct them, right? Let's take an example of, like, you know, let's say your golf you're talking about here, or any other sports, let's say badminton or cricket, etc., right? People talk about, okay, this person actually won this event. This person as a team player is kind of, you know, scoring centuries after centuries, right? But what's going behind that is important to understand. How many hours of practice that the person do? What is the food habit of that particular person? What does this person eat or doesn't eat? What kind of, you know, what kind of time does this person kind of, you know, sleeps, right? Even when he is sleeping, if you're kind of, you know, wearing a smartwatch, then it kind of, you know, gives you a behavior of your sleep pattern, right? So all this various analysis or analytics that, you know, you take into, and then you kind of, you know, construct. And again, there would be a role like a dietitian who would be talking about a certain way in certain things that, you know, you need to eat. There would be a coach who would be talking about you need to do, like, you know, maybe 5 sprints around the ground, because the 6th sprint you may need to take some break breather for 10 minutes and then do again, right? Because your body as a sports person is probably suited to 5 at a time, right? So all these various nuances, you kind of deconstruct the entire journey into blocks and buckets, and then you kind of connect the dots and say, if a player is able to do XYZ, then that is what leads to this person actually performing well on the ground, right? So there's a lot of science that kind of goes behind in deconstructing the models and analyzing and understanding and developing a pattern for it, which then when you are kind of communicating with the sports or the teams, etc., they are able to kind of take it and then apply, right? So I think that's the basic fundamental that we should keep in mind. So even in your careers, if you are looking at any role which is to do with data science or analytics, and in any industry for that matter, we are talking about sports here, but it could be any other industry, I think it is important to think in a different way always, because you will always be presented with various different sets of data and various details of information. How do you deconstruct that? What do you pick? Where do you stitch the story? Where do you connect the dots? I think these are the important things to kind of keep in mind when you are kind of doing the analysis, and when you are looking for the to kind of talk about how do I implement that in the actual practice, right? So I think this is going to be important. Let's also listen about what new data scientists should learn. While there are certain standard things that data scientists are aware of, but what are the few new things that they may kind of learn, which is something different, or which is something which is additional to the skill sets, right?
Okay, so if you are, let's get the shortened version of the Kenji, what to do if I wanted to learn data science over again today. What would you do, and how would you go about it?
So the first thing I would personally do is learn how to program. I think that programming is the gateway to a lot of other things, right? Like math is unbelievably important in the domain, but if you know how to program, you can implement the math. You can get your hands dirty. You can experiment with it. You can use the random number generator to understand how distributions work. Programming gives you the tools. It's like giving you a pen to be able to write an essay, right?
Mm-hmm.
I find that if you don't have a pen and you're trying to write something, just like planning a speech in your head is pretty difficult. Writing it on paper makes it implementationable and actionable. The next thing I do is look at what other people are doing. I used to say the second step is to just jump into projects and getting your hands dirty. I think that a lot of people panic and freeze when they're told to do that. And so I just recommend going on Kaggle, going on GitHub, and looking at projects other people have done. Follow along, copy the projects into the terminal and run all the codes. Don't take credit for the work, but just figure out what it means when you change a parameter and what happens to your model. Figure out what these things do, experiment, play around, right? And then that leads into actually doing your own project, right? Finding data that you're interested in. If you're interested in the data, you're probably going to be more inclined to stick with it and start analyzing it. It doesn't have to be good, right? You look at my first video, it's garbage, right? But I leave it up because people can see how far I've come.
Same.
And so I think that really those three things are what all learning is about, is just iterating on that and just continuing to learn, observe, and implement in as tight loops as you can make.
So very nicely and simply put. So he talks about what are probably the three most important things, and he says programming is a very important aspect. While you may be very good in mathematics, and maths is important, but then if you understand programming, you can fit in the maths over there, right? Then he talks about learning and observing. Just because you understand programming or maths, does it mean that you'll be comfortable jumping onto a project straight away? Probably not. So where can you learn about what's happening in the world? Maybe GitHubs of the place where various folks are kind of submitting their details, and there are projects, etc. So maybe you pick up something and then you get your hands dirty. You try and experiment yourself first, right? Figure out, fail, and then understand which formula works better, which programming works better, what are the possibilities, etc. And then when you feel comfortable, then I think it's good to get and delve into a particular project using data science, right? Now, he also talks about something which is very important, that while you do all of these things, it is important that it's a continuous evolving and learning, and that is what it talks about. So it is not a one all and game over. No, you do it, you learn, you iterate, you take a feedback, you observe, and there are multiple ways in which you continue doing that, and that's what is going to be making you successful, right? So these are a few things which the author talks about as a data scientist, what is an approach I can take, and these are practical experiences of success, right? So it's always good to kind of listen to it. So let's listen more, what does he say?
Yeah. Yeah. I've been studying language for a while. It's kind of the same thing. Like until you know how the language is structured, you can't really, make a sentence very well other than memorizing things. So, learning that programming language is kind of like that. Are there any specific ones you recommend for someone that's learning?
Yeah, so I will say there's a prerequisite step that I forgot, and that is really important, and that's to do a little bit of breadth of understanding of the domain, right? Like watch a lot of videos, understand what data science is, understand what the components are. It's kind of this meta idea about what is data science and its components, and then structure your learning a little bit. So I say learn programming first, right? But what elements of programming are important? Those are pretty easy to find on the internet, right? And then like understanding how to use modules is really important, or libraries, or whatever you want to call them, because data scientists, we're not coding, we're using pandas, we're using just libraries and implementing it, right?
NumPy and all that stuff.
Exactly. So that's how I would approach it. I personally recommend learning Python. That's a more popular language if you're looking at the data. Like it's in higher demand for jobs and things like that. I think R is fine too. My recommendation is to just choose one, stick with it, learn it well. If you learn one language well, you'll be able to learn another language relatively easily. All of the programming languages have core concepts that are the same. They have variables, they have loops, there's functions, and there's classes, right? In most languages.
They call things differently, which drives me nuts. In R, it's a vector. In every other programming language, it's an array, right? Yeah. And it's funny though. There's a funny backstory because I used to I had a data science team in my org back at Pluralsight, and the director of that group, she was a fantastic data scientist. I talked to her about that one day. I said, why? Because she told me you need to go learn R. And I'm like, fine, I'll go learn it, because I was a Python guy too. And I'm like, well, why do they call it that? This is what it's called in Python and literally every other language. Why do they call it differently? Like the vector example. And she said, because we, math in the world of math, we would call it a vector. And I'm sorry, but math has been around longer than Python. I'm like, fair enough.
Yeah.
Fair enough. But yeah, there's a lot of oh, that's what you call that. Okay. So this is how I do the same thing. Which is, often, I agree. It's not transposable, but it's like if you know Java, you basically know C#. They're very similar languages in terms of how you structure them, just a few different words here.
Yeah. So here, the key message is while he talks about learning programming, but what in programming, or what are the similar languages, or even the analogy, if you know X, then it is automatically easy to kind of know Y, right? So these are some things which I think practically, when we are thinking of how do we start our journey with data science, I think we need to, at the very initial stages, do this research, watch a lot of videos as he talks about, because this field is a huge field. It's not only about, oh, I want to become a data scientist, but then it's all about okay, how do I do that? What is the right and a structured way of kind of doing that? And then how do I apply that in my practical field? In this case, it is sports that we are talking about, right? So I think it's very important to kind of keep this in mind. So I hope you kind of listened and noted it down, how the interviewer and this person was talking about the sequencing, whether I should be using a particular language to learn first, or something else, or what should the approach be, right? So that's there. Finally, let's look at what's the job market for data scientists, and this is something which obviously everybody is kind of interested, because ultimately whatever we do, we also need to understand how is the job market and where does it kind of help us, right? So let's see how the job market for the data scientists are like.
What do you say? I mean, it always seems, and maybe I'm just biased, but always oh yeah, if you are good at data, find a field you're interested in, and there will be a job for you. Do you find that still to be true, like the job market for data people?
I think for the most part, yes, it is true. I think if you differentiate yourself and you show that you have that domain area, absolutely. I mean, one thing that a couple of people have recommended is do the work that you want to do, and then you'll find a job doing that, right? If someone came to me and they had a portfolio of like 5 sports analytics projects, they clearly knew what they were talking about, they've already done work that we could use as a company, I'd be pretty inclined to look at them very seriously, right? If someone is, if someone has done work that we can take as a company, they've already done it, we know the quality of it, and we can give it to our clients that would provide them value. Like, isn't that a no-brainer? Isn't that a reason to hire someone? And so to me is, if you've done the work and you're interested enough, enough about this domain, that is a huge differentiator. People look at in data and in software engineering, probably more relevant in data, but they think that the only thing that differentiates them is the technical skills. And I'll tell you that is absolutely not true. Like, there's so many other things that are important. The way I look at it is you have a baseline that you're what I call, or in business they call a strategic minimum, right? If they're good enough at this, we'll take them. The rest of it is everything that we care about. Like, for most people, the technical skills are a binary variable. It's a 1 or a 0. And then everything else is what will make them hire you, right? Like, are they organized? Do they know how to use, I guess versioning is technically a technical skill, but that's how, like, we evaluate people. That's how I've seen very successful people evaluate others in the past. And you're not hiring someone to just only have them do technical work. You have to spend time with them. You have to collaborate with them. You have to understand what the output of their work is. There's so many other things that you can show through having relevant work and having that subject area expertise. I see so many people transfer into data science or like try to jump into the career, and they try to erase what they did before. And I'm like, no, that's useful. That's like your edge. That's something that you have that other people don't. Like, if you worked in accounting, you worked in finance, like, try to find data roles that are related to that, because you have half the prerequisite skill set already.
You have that subject matter expertise. Yeah.
And
kind
to
of
me,
domain knowledge.
And people just overlook that so much. So I would, shout it from the rooftops if I could.
That's awesome.
Great. So the learning here in the final script is what he talks about is that the job market is always going to be there for a skill sets like a data science. There is no debating that fact. But what is important is that, as we talked about earlier as well in the class, that data science is a very vast field, and it is applicable in multiple use cases. So just because you have a technical knowledge doesn't mean that you are a good data scientist. Because, as the author also says, and any one of us who has worked in the industry, or when we want to hire somebody, or when we want to kind of work in a team, we want to hire somebody who is able to collaborate, who is able to think like a business, who is able to bring in that strategy. Technical skills is just one part of it, but only having technical skills and not having your business skills or any other soft skills which is kind of required is not going to lead you far. So imagine a scenario where, again, we'll take an example of a sports as an industry. You may be very good in your technical analysis, but if you are not able to communicate that to the sports person, then the sports person doesn't benefit. So which means, in your communication skills, your ability to understand what will make an impact, your ability to understand and foresee the future, analyze the trends, and then let the sports person know that because I have done this XYZ, and because this is the requirement, and this is how it is ultimately going to be helpful, right? A lot of times what happens is when people who are very strong in technical knowledge, they are unable to communicate to the business. And if you are unable to communicate to the business, then the technical knowledge doesn't really become fruitful, because a business person will always want to understand, okay, fine, great, you have done the analysis. So what do I do? Tell me the 1, 2, 3 things I should be doing. So if you are not able to communicate that, because you don't understand the business, then that becomes a challenge. So hence, it is not only about the technical skills, but it's also about like a lot of other things that go around with it, right? And that's the key message. So the question is then, is the data science field a good field in terms of jobs? Or do we have enough jobs? Do we have enough data scientists kind of in roles opening up? Yes, plenty. As long as you know your subject well, there's going to be a plenty offering. But then what do you do after that? What is the actual implementation? And I think those are the things that people would want to see when they're kind of hiring you or looking for something. And it could be projects, it could be other jobs, etc. Because not every time you will have a job experience, but then have you worked on certain projects, or do you have that bent of mind of thinking that if a problem is given to you, you're able to kind of solve that and take it out and implement, right? So I think these are things that I think the thought process or the bent of mind or the application is important, and hence understanding business goals, or what is going to be the final success metrics or implementation is going to be kind of an important, right? So while we talked about sports as an industry, and this is a very interesting industry in terms of data analytics, but then every industry for that matter kind of utilizes this. You take any industry, it's all about data at the end of the day, right? So while we took this example, but then it is applicable across all the industries as well. So that is the learning I want to kind of leave all of you with, and would urge and request all of you, when you are looking into any kind of data projects, right? Even if you're not a data analyst per se, but then you're not a data scientist per se, but in your day-to-day life or in day-to-day work, in your student life, you would always be dealing with data. The thing is, how are you interpreting them? How are you extracting the right information? And what can you apply and map it that to, right? I think these are few key things you should be kind of keeping in mind. And then I think you develop that mindset of data analysis, right? So that is the key takeaway I would want to kind of leave with. So any questions you have for me, anybody from today's class? Anything, anybody, any questions? Okay, if we don't have any questions, I think we are good for the day. So okay, so Maharishi kind of mentions in the chat that no sir. Okay, fine, thank you so much. So Kioni's Karnataka team,
Yes, sir.
I think we are good with this class, right?
Yes, sir.
And we shall see again later this week for some other topic, right?
Thank you, sir.
Okay, all right, thank you so much.